In our last class, we were talking about absolute value equations. And if you remember, we solved those twice. We're now moving on to the absolute value inequalities. And we're going to also have two solutions for these. There are certain conditions that tell us which type of inequality they are. And we'll be looking at the inequality symbol to help us decide whether it's an and or an or. In this first transformation here, I'm not going to go into the details of the general formula because sometimes that's a bit confusing, but I'll let you know that in this first type, which is the less than symbol cannot be replaced with a less than or equal to, but in the second, where it's greater than, it can be replaced. The examples are really what will help us to make sense of this, so let's go right on to the examples. We're going to solve an inequality in the form first of the less than type. So less is going to be the and type. So if I'm looking at how I'm going to set this problem up, think of my and inequalities. I'm going to, as they say, nest this in the middle. And I'm going to take this, remember, positive 4 or a negative 4. So I'm basically writing two inequalities, and I'm going to solve it like I did any other compound inequality. I will subtract 6 on both sides. I get negative 10 is less than x, which is x is less than negative 2. And we can go ahead and set this up on a number line, finding negative 10 here, and a negative 2 here, open circles, and shading because it nests in between. Less is a nest. All right, so we go on to a second one. Again, we can rewrite this as two separate inequalities, which is originally how I approached this, by flipping the sign and changing the symbol. But I'm finding that this is easier to explain, so that's why I redid my original video to give you this format, which I think is easier for you to follow. Remember, the boundaries are going to be negative 5 and 5. And what's in here will nest in the middle. So these are less than symbols. And I'll have negative 7 plus x. I'll now add 7 to both sides and the center. And I get 2 is less than x, and x is less than 12. And again, we wrote these as two separate inequalities last week, and then we graphed them on the same number line. Well, if the less nest in the middle and shades in the middle, more is or. So let's remember that as we set up these next problems. X plus 6 is greater than 12, or x plus 6, reverse the symbol, change the sign. We'll now solve twice. We get x is greater than 6, or x is greater than negative 18. This would then be graphed on a number line going in opposite directions. Let's just say, for the sake of argument, that negative 18 is down here. And let's suppose 6 is far to the right here. Open circle, shading everything greater. Open circle, shading everything less. Ors in opposite directions. All right, so I think after doing my first video, I realized that this would be a much easier way to remember. If it's more, it's an or. X plus 1 is greater than or equal to 3, or that's when we rewrite it and reverse it and change the sign. Flip and change the sign. Let's subtract 1 on both sides. X is greater than or equal to 2, or let's subtract 1 again. X is less than or equal to negative 4. Again, I'd find 2 on my number line, and that would be a closed circle this time and shading. And then I'd go on the opposite side and close circle again at negative 4 and shading everything that is less than. So if you can think about less nesting, less is nest, and more is or, you're in a good place. Let's try one or two more. I've set this one up for you because the less is the ones that nest in the middle. This is a two-step. I get negative 18 is less than 2x, which is less than negative 2. This is a two-step, so I have to keep isolating my variable. Negative 1. And there's my solution. I see greater than and more is or. So I'm going to do the 2x minus 8 is greater than 4, or 2x minus 8, flip the sign, okay, reverse and change the sign. So now I'll solve twice. It's a two-step. I get 2x is greater than 12, so that x divided by 2 is greater than 6, or let's add 8 to both sides. I get 2x is greater than 4, divide by 2, or x is less than 2. There's a couple more here, and we'll do those in class. I hope this was helpful.